Holy moly. All right, guys, we're learning Python scope stuff today. So we're doing boot.dev again. We're going to learn scope. We're going to learn some scope stuff. What time is it? It's about 8 a.m., 7:50. Just turned 8 a.m. Sweet. Guys, I don't know what happened last night. I don't know if I like bit my lip or something, but it's so swollen. So I might have a lisp in today's episode. Guys, what is going on? So we're back in boot.dev, level 8 wizard. Don't mess around with me. Don't mess around with me. We're going to learn a little bit about scope. Scope, from what I understand, you have different access to different variables. There's things called child scope, parent scope, scope, things like that. So in grandchildren and things like that. But it's defining where you can use stuff, how stuff is related to each other. It's the scope. It's the scope. So let's dive in. Let's learn about it relative to Python. Excuse me. I got the coffee burps. Let's dive in. Scope. Scope refers to where a variable or function name is available to be used. For example, when we create variables and functions by giving names to our parameters, for example, big sip, that data is not available outside of that function. So this data right here is not available anywhere except for the subtract function. Or right here, here's what it's saying. So I can't print x because x belongs to this. So this is the child scope, and this is going to be the parent scope. So I have access to the parent scope in this file, right? So over here, if it says don't touch above this line, but we're gonna break some rules. So if I wanted to access the get max health, I can, but I can't access things, the modifier. If I want to print the modifier, it won't work. If I want to print the level, that won't work. So let's keep reading. When the subtract function is called, we assign 5 to the variable x, but x only exists within the subtract function. If we try to point at x outside of the function, then we won't get a result. We'll get a big fat error. So I hope that kind of makes sense. Assignment for the bug on line 10, max health. We cannot access the. Wait, we should be okay. This looks kind of fine. We're using variable names from the wrong scope. Fix it. So we have, my modifier. That's what it needs to be in my level. So I hope that makes sense because these things exist here, but let's say in an alternate reality, they existed up here and they were nested within this function. This would no longer work. This would break the function, but because they exist over here, let's see if we can adjust it. Nice. We can now access it wherever we want in the file. So that's a bit about scope. And let's say if we wanted to define a new function, well, let's see if this is right first. It is. Sweet. So let's break it. Let's do the inverse. So that's the working code. Let's learn about the the code that does not work. So let's pretend we have a new function, and we'll say this takes x and y, and this new function return. We'll just say x plus y. I would not be able to print x, and that's exactly the result over here. We'll see, destroys the code. X is not defined, has no idea what it's talking about. However, if I put the same print statement, right, let's fix it here, it would work. Nothing changes. And we actually didn't print anything there's nothing, this function is not being invoked anywhere. So there's no X being called. But yeah, so first lesson, guys, we're off to a hot start, 8 a.m. Perfect. All right, so global scope. So far, we've been working in the global scope. That means that when we define a variable or a function, that name is accessible in every other place or program, even within our function. For example, pi is 3.14. We can access it in this function because it's global scope. It's on that first line or that first indentation, and we can use it in any indentation. It's not just the indentation though. It's also not nested to a function. It's also important to right there, but that's one way to think of it is the indentation. Because pi is declared at the top of the file and at its own deal, we can use it everywhere. So assignment, let's change how we calculate the player's stats. Things we need to define globally is the character level, and then let our functions do the rest. Declare the variable player level at the top scope, set it to 4. Okay, so all it's asking is just to do this. Oop. Set it to 5. That would be so funny. Boom. Okay, cool. So I hope that makes sense if we set player level because it's being used in 2 spots. And this is software in a nutshell is do the thing with the least amount of work and the least amount of maintenance. Yeah, I was going to say maintainability. But so for instance, you could do player level like this, and I bet this will still pass the test. Let's see. It still does. But the problem with this, just foreshadowing to software engineering concepts down the road, if let's say this function existed in a random file over here in our project, and then this other calculate health function existed in another file way over here in our project. If we wanted to adjust player level, we now need to make sure we're adjusting it. If like for whatever reason we need to upgrade the player level to 5, we now need to adjust it in this file and this file. And that's where you can cause problems. So what you really want to do, and roughly this is what kind of pointing is pointing to the same area in memory, is you have both these files. Instead of them having their own data, they actually point to one file where you have the data. Or in this case, you have two functions, and instead of them, and this is perfect. This is a micro version of what I'm talking about, but the macro version is you have a file over here that's maybe 100 lines of code. You have a file over here with 100 lines of code. You don't want to maintain 2 sets of data, or you might have 3, 4, 5, 10 files. You don't want to maintain 10 files. You want to maintain one file that distributes the data to those 10 components, or those 10 features, or those 10 functions. So in a similar, in a smaller fashion, here we have 2 functions. You might have 10 functions that use the player level. You don't want to have to maintain that everywhere you go. You just want it to point at one location, or as little amount of locations as possible. And it's a lot more maintainable. So can functions access variables declared? Yes. But the point is that's programming in a nutshell. The reason why scope and pointers are really important. Sorry guys, I've got a swollen lip here. But the reason why pointers are important in programming is because we can. It's the dry concept. Do not repeat yourself. DRY. Do not repeat yourself. So the least amount of work is pointing at the same location in memory. So can code outside of the function or outside the scope of a function access variables inside of that function? No. All right. Unit tests. Sweet. Guys, we're in chapter 5. Sweet. Well, let's just cruise through. Unit test and scope. We're testing and debugging and scope. And the same freaking thing. Sweet. Okay, so up until this point, all the coding lessons you've completed have been testing. Well, I'm debating in my brain. Do I just wrap this episode up now because we could separate things? This is the scope episode. This one's for unit testing. It can kind of break things apart for y'all. Yeah, let's do that. I'll break it up for y'all. We'll be right back for chapter 5.